Welcome to the presentation of the final paper of the course Introduction to Machine Learning by Tuan Nguyen or Eli. In this presentation, I will talk about the topic vehicle re-identification on competent baseline with powerful visual representation. In this representation, I will give the understanding of re-identification problem and its application. I will call ReID in short. Then I will talk about the data analysis, and data strategies for training, validation, and testing. After that, I will discuss about the methodology that I use to solve this re-identification problem. Finally, I will show the result and my conclusions. Firstly, about re-identification problem. Given the gallery of images from multiple cameras and the query a vehicle, the task is to find or identify this vehicle across the multiple gallery image. It has a lot of application in intelligent transport system, such as vehicle detecting, vehicle tracking, counting vehicle abnormal detection, and the event recognition like traffic accidents, tracking through traffic. About the data, we use very data, which is the very popular data for re-identification problem. It includes more than 50,000 images of 776 vehicles from 20 cameras in the real-world urban scenario. In average, each vehicle has 64 images. Here we have the link to this public dataset. However, I need to email the author to ask the client to download it. And I use first 400 vehicles for training sets, the next 200 vehicles for validation sets, and the last 176 vehicles as test sets. About the methodology or the baseline, I use the winning solution of AICT Challenge 2020 Track 2 to solve this pre-identification problem. AICT Challenge is the very famous challenge to solve the smart cities problem regarding the traffic, and Track 2 is the identification problem. So I use the latest solution, maybe the state-of-the-art solution to solve this problem on another dataset of very dataset. We have the source code and the paper here. About the methodology, although I use the solutions of the winner, I don't use all of this. I just use a part of this because some technique is not suitable for the very dataset. For the synthetic, firstly, we need to synthesize the data, synthesize to get more data. I use the content manipulation technique, which implement a DGNet to generate a sample with different visual appearance. Digitally, it employs two encoders respectively. The first encoder responsible for appearance here. The second encoder responsible for the structure. And the final decoder generates the structure from one image to the appearance of one or another vehicle to generate a sample. This is very useful for identification problem because it's hard to deal with a similar case in real world. About the representation learning, there are three parts. I will talk about our network structure, the optimization function, a loss function, and the implementation details. For representation learning network structures, This is the combined network, the combined architecture from ResNet 101, ResNet 101, 32 is 81, ResNet 50 IBM, and here the structure of the architecture. In that, the log 3 and log 4 are the activation loss and the activation of last two blocks of the image net backbone. GAB are global average pooling. GMP are global mass pooling. Two of these used for extracting the global features to fit to the headlock. AAP is adaptive average pooling. AMP is adaptive mass pooling used for extracting the local feature to fit the headlock. In the headlock, we have the batch normalization layer followed by a leaky ReLU function layers and a convolution layer. Next is another patch normalization layer, and the final is fully connected layer. About the optimization function, we use two loss, that is the ranking loss and cross entropy loss. For the ranking loss, it's focused on optimizing the distance of training sample. It does two work. The first work is to pull the feature of positive pair closer, and the second work is to push the feature of different vehicle far away. Here we have a triplets, SA, SP, and SN. In that, SA and SP are the sample of same vehicle. SA and SN are the sample from different vehicle. The ranking loss will compute here. While DAB is distant from SA to SP, DAN is distant from SA to SN. We can see that it's trying to make the same vehicle, the image of same vehicle closer, and make the image of different vehicle farther. That is more different. Gross entropy loss is one of the most popular loss function used in machine learning. This is formula. About the implementation, firstly I will talk about the learning rate. I use the base learning rate 0.001 and the learning rate decade strategy with the cosine strategies. The formula cosine strategy here. It is similar to the original work. The number of each pouch. Firstly, I trained the model with 88 pouches, but after I observed the loss while training, I realized it may overfit, so I just chose 58 pouch as the number of edge pouch for training. About the synthetic data, I have conducted an application study to check if the synthetic data have improved the performance of model. And we can see that it have improved about 2% mean average precision from without synthetic data to with synthetic data. So I decided to use this synthetic data. Please note that this synthetic data were created by content manipulation technique that I mentioned above. And the last one the last technique that I use is pre-ranking technique. I have do an application study to check its performance, and it have improved the performance of model significantly, nearly 11% from 45% to 94%. Here the explanation of the ranking technique. We have a group, we have a gallery of image. The green box here is the positive image. We can observe that the positive image usually have the neighbor is the positive image or pro image. So the assumption here is that Within the gallery of image, the image that have the relative is the positive image are likely to be positive. The detail of this algorithm I have explained in the paper. About the result and conclusion, here is the result. Uh, Here our result compared with other works in the same very dataset. Our result is 55.15% of mean average precision. And we can see that the result will improve over years. The latest one may be the state of the art is 83%. Although our results is not impressive comparing to state of the art, I believe that it could be improved greatly if applies more post-processing technique and more technique from the original work. I cannot do that because of the limited of time and resource. Thank you for listening.